The Gumboro disease, or infectious bursal disease, is caused by an aviburnovirus which was first described by Albert Cosgrove in the early 1960s, from a clinical case that occurred on a farm located in the small town of Gumboro, Delaware, USA. Within a few decades, the virus has spread to almost all the poultry industry worldwide, and because of its high resistance in the environment, it is nowadays present in virtually every chicken farm, causing concern about its negative impact on poultry production. A large number of vaccines have been developed aiming to control the Gumboro disease. Most of them, when correctly applied, have demonstrated to be efficacious in protecting the birds, but only a few of them can be used when a full control of the disease is needed, which means not only controlling the consequences of the infection in the bird, but also preventing the selection and emergence of new Gumboro virus strains, and avoiding a build-up of existing field strains over time, putting more challenge pressure on the flock. As the Gumboro virus is extremely resistant, the poultry houses will remain contaminated even after the cleaning and disinfection procedures. So, for the next flock, the challenge is unavoidable and will put on pressure as soon as the chickens arrive. Early infection is by far the most detrimental, since it has a strong negative effect on humoral immunity. After 2 to 3 weeks of age, the consequences regarding immunodepression are much more limited or even absent. It is impossible to protect the young chicks against early infection by vaccination. The only way is to provide them with adequate passive immunity, which should be achieved using adapted vaccination schemes in breeders. The active immunity induced by vaccination will normally ensure continuous protection needed after passive immunity. Vaccination has an impact on the evolution of the disease at farm level. The Gumboro virus is likely to evolve, and because of these possible changes in its antigenic and biological properties, control of IBD must also take time into account. What is done today will impact on tomorrow's situation, and what can be apparently working well for a few or even several rounds might turn out to be detrimental in the longer term. 3 types of Gumboro vaccines have been developed to induce active immunity for broilers: the conventional live vaccines, the immune complex IBD vaccines, and the vector HVT IBD vaccines. Conventional live vaccines suffer difficulties to overcome given levels of passive immunity, so the vaccination date determination should be carefully analysed, and so should the reliability of the vaccination coverage when performed at farm level, which was revealed to be insufficient for adequate flock protection. The immune complex IBD vaccines are complexes formed by the combination of a carefully selected Gumboro virus, which up to now is the Winterfield 2512 strain, covered by specific antibodies in a stable form. In this way, the vaccine is not affected by passive immunity and can be safely applied to embryonated eggs or day-old chicks, immunizing the flock on an individual basis. Vector HVT IBD vaccines are made from a genetically engineered virus called the vector, whose genome contains a gene from a specific Gumboro virus called the donor, encoding for one portion of the VP2 protein present in the capsid of the selected donor. Both immune complex and vector HVT IBD vaccines can be injected systematically in the hatcheries using the in ovo or subcutaneous routes with a high degree of reliability. However, these two are very different types of vaccines, and it is necessary to understand their mechanisms of action and respective advantages to make the right choice and get the most out of them. Controlling a disease includes both protection of the susceptible animals against the negative consequences of the infection and prevention of the disease, that is to say, the reduction of the probability that the birds will be challenged. Control equals protection against the losses plus prevention of the challenge risk. For non-resident diseases, which are the ones coming from outside the poultry farms, such as Newcastle disease, avian influenza, and infectious bronchitis, amongst others, the protection comes from the vaccination. This makes the chickens more resistant to the infection. Prevention, however, comes mainly from the biosecurity measures. In the case of Gumboro disease, the causative virus is almost always present inside the farm in the litter, so the vaccination should aim at both protecting the chickens from the losses produced by the infection and preventing that the challenge risk get out of control. This is what is called controlling the Gumboro disease. For this reason, the objectives of a Gumboro vaccination program must be to ensure a continuous protection against infection by the resident farm Gumboro viruses, to prevent the buildup of higher virus pressure round after round, and to prevent the evolution of the farm Gumboro viruses towards a virus that could later escape the protection program. A comprehensive vaccination approach should consider the vaccination program in the breeders, using kill vaccines in order to generate adequate maternal immunity to early protect their offspring, and vaccination in the broilers to generate the active protection that should be able to start even in the presence of passive immunity. This will ensure the continuity of the protection. So, an effective Gumboro vaccine should be able to be successfully applied in the presence of passive immunity without causing any immunodepression or any other detrimental side effect. And an ideal Gumboro vaccine should be efficacious not only protecting the chickens, but making the broilers resistant to infection. So the shedding of the field virus will be reduced, decreasing the pressure for antigenic selection in the environment, limiting in this way the likelihood of the emergence of new strains. In other words, an ideal IBD vaccine should be able to control the Gumboro disease. All live conventional immune complex IBD and vector HVT IBD vaccines have demonstrated under laboratory conditions that when properly applied, they were able to protect against the consequences of the infection. But under field conditions, the situation can be somewhat different. As it was mentioned before, conventional live Gumboro vaccines have the drawback of being easily neutralized by the passive immunity and the inadequate coverage of the population, consequence of the drinking water administration. So, under field conditions, the protection elicited by this type of vaccine is quite heterogeneous. In the case of the immune complex IBD vaccines, recent scientific studies have demonstrated that the Winterfield 2512 strain present in it can replicate fast in all follicles of the bursa, fully protecting them within a few hours, triggering all arms of the immune system and making the chickens highly resistant to infection, whatever the type of Gumboro virus challenge. No morphological signs of challenge virus replication in the bursa can be seen. Under field conditions, the consequence is very homogeneous protection. Vector HVT IBD vaccines generate an immunity that does not come from the replication of a whole virus which triggers all arms of the immune system, but comes from antibody response to the VP2 antigen of the IBD virus expressed by the HVT vector. Therefore, the induced immunity is mostly, if not exclusively, of the humoral type. An important fact that has been recently confirmed is that the level of protection induced by the vector HVT IBD vaccines is dependent on the Gumboro virus strain that is challenging the chickens. So this protection is more effective against field viruses which are more similar antigenically to the VP2 present in the vaccine. Also, in the vector HVT IBD vaccines, the protection does not come a few hours following the replication of the virus, but builds up progressively from a few days to a few weeks after injection. So, that level of protection depends very much on the age at which the chickens are challenged. If the challenge comes early, the consequences of the infection become obvious. As previously explained, the prevention part comes from the ability of the vaccines to reduce the load of the existing virus population in the environment and to decrease the risk of new strains emerging. With the conventional live Gumboro vaccines, because of the maternal immunity effects and the difficulties for proper administration in the field, the vaccination coverage is far from perfect. Many birds never take the vaccines, so when the flock is challenged, the field Gumboro virus replicates in the susceptible animals, increasing the buildup in the environment cycle after cycle. With the vector HVT IBD vaccines, even if clinical protection is present, the protection induced is limited. These vaccines do not suppress neither the infection of the bursa nor the shedding of the field virus, and consequently, the load of virus population in the farm will increase cycle after cycle. Also, the strains that are less protected by the vector HVT IBD will replicate more in the bursa, consequently being shed into the environment and becoming more prevalent over time. The long term will favour the emergence of new Gumboro strains. Vector HVT IBD vaccines protect to a certain extent from the consequences of the infection, but don't prevent the challenge risk increase. As for the immune complex IBD vaccine, the fast bursa colonization has demonstrated that the vaccine is capable of blocking field virus replication, and consequently, the shedding of the challenge virus is reduced to low or almost undetectable levels, whatever their antigenic challenge type. This key characteristic is unique for this type of vaccine. This complete protection or blockage of the bursa means that after successive vaccination cycles, the virus load in the environment is greatly reduced, without exerting any selection pressure on the population. This way, the vaccination does not assist the emergence of new strains. Today, the immune complex IBD vaccines are the only ones that can effectively aim at the prevention part of Gumboro disease control at field levels. In conclusion, when aiming to achieve the control of Gumboro disease, the strategy chosen should attempt not only to decrease the losses caused by the infection, which in other words means protecting the birds, but also look to decrease the risk of the flock being infected by preventing either the build-up of the field Gumboro virus or the emergence of new strains. Besides the advantages of being administered in the hatchery without any interference with the passive immunity, which covers almost 100% of the flock, only the immune complex IBD vaccines are able to protect the birds and prevent the challenge, meaning full Gumboro control for today and tomorrow's poultry industry.